Hi, this is Alix Paultre, and today I've got John Weber from TechNexion. He's the business development manager, and well, we're here at the Embedded World Show, which is a huge, huge show. How are you doing here?
Doing great. This is my first time at Embedded World, and it's a really big show. So I'm very excited to be here with the team.
Well, and you've got a lot of nice things here because, well, let's just start from brass tacks. Embedded development, there are so many protocols, so many technologies, so many products, so many processors. You got to put them all together somehow. I mean, there's got to be some rhyme to this, jumble of parts and electronics to create the embedded systems that we're trying to develop.
Well, absolutely, and kind of that's the reason why TechNexion exists, right? It's because we want to make life simpler for customers that are trying to do just that. They're trying to put processors and memory and peripherals and voice, for example, together, displays, touch panels. Trying to put all that together into a system is actually very, very complicated, and the reason why we exist is to try to make that a lot simpler for customers to get them to market a lot faster.
Well, exactly. Well, because the engineer, he's got a client, and depending on the application space, he might have regulatory issues, right, compliance issues, a lot of moving parts.
Absolutely, and just a really quick aside, right? One of the reasons why we built our own RF modules, like this one guy is an example, right? This is an RF module that we've designed, and we're certifying this for the U.S., for Europe, and for Canada, as well as for Japan. So we'll be able to take that and plug that onto all of our products so that they'll have a fully certified solution once it's done. And really that's something that we're seeing a huge growth in is the addition of wireless to embedded systems. And it's not just Wi-Fi and Bluetooth, it's also Zigbee and Thread and other protocols as well. And that's the reason why we actually have an expansion module now capability for all of our systems to be able to easily add that on. Yeah.
Well, because the issue is it's an orchestra, right? And they're the conductor, and they're trying to make sure that the first violin doesn't clash with the oboe, and I mean, it's a balancing act. And so, having said that, I see you have a bunch of different modules in your talk. Why don't you run through some of the things? Like, let's say I'm an engineer, I walk in the front door and I say, I've got a harpsichord, and I want to be able to send data from the pastor to the the person up there, little display. I also want to maybe have some feedback for the choir. I mean, older systems, modern needs.
Yeah, no, absolutely. But I mean, one of the things I think that we want to help with in our customers is tell us a lot about what you're actually trying to accomplish, because we may have all the Lego blocks that you're looking for, right? That we can plug them all together and help you build the system. But without really understanding that up front, we can't really help you that much. We can just show you all the things, right? So we have all the things. What we really need to be able to do is say, okay, tell us what you're trying to do so that we can help you pick the right things. And then also, silicon that is not running any software is just really sand, right? So let's talk a little bit about also the software solution that would be required in your application. You brought one up. You have a harpsichord. It's in a church. It needs to get data from the harpsichord all the way up to the speaker system, right? And it needs to be recorded at the same time. So in those kinds of cases, what RF protocol are you going to be using, right? How are you going to be sensing the sound from the harpsichord? Do you need to be able to also add other sound to it, right? So all of those things kind of bundled in together. Come talk to TechNexion, come talk to us about what you're trying to do, and we'll try to take, for example, some of the products that we have, like in this case, we call this our voice hat, right, where it's built to use Google Voice as well as Alexa voice. We have buttons on it, we have all this. This is really just an evaluation design, getting customers up to running very quickly, so we could potentially use that to capture data from your harpsichord, right? And then we have the RF capability directly on the module, or we can add another module on the back here to be able to add additional RF to it, so we could just easily plug that on. And then for example, we could have it talk to other smart systems in your church, right?
So security, or presence detection, or whatever.
Absolutely, absolutely. And if you need to, for example, have some sort of each human-machine interface, like a HMI or something. We have this kind of box. We have a full line of HMIs, anything from 5 inches. This is kind of cute, little HMI. But we have
right under the altar. Right under the altar, the priest can send messages to the.
Yeah. No text messaging while you're preaching, though, please.
Which brings us to another issue: security. Right. So let's say I have a system, and I've got lots of people with cell phones in there. They might have remote vehicles. They might have kids with toys. There's a lot of RF noise out there.
Absolutely. That's right. And that's why you want to make sure that when you're designing your system up front, that you're designing it with security in mind, specifically for your application. I mean, you could try to lock something down as tight as you can possibly go, but there's a cost commensurate with being able to do that. And really, you just need to audit what it is, what you think your vulnerabilities are going to be, and your areas of really critical need. So, for example, if you are building something that is going to be system critical, but yet it's going to be behind a firewall, right? What you probably need to guard against is security vulnerabilities from inside the firewall, right? So people, tamper detection, things like that need to be built in. And we have that capability in some of our larger system products, which is something that we can show you here. But we can also provide you with some advice, guidance, and insight on how to build that kind of capability into your system, say if you're using one of our systems on module products.
Well, like we're looking at some of these systems, and just why don't you walk us through just like a little bit of a rudimentary what kind of modules? Because you were saying obviously you have to know what they want to do, but give us a little bit of an idea of the modules available so that way our audience can go, hey, I should call these guys.
Yeah, well, sure. Okay, so TechNexion really has, in terms of hardware, we have 3 families of products. We have systems on module, which are built basically entirely encapsulated processor subsystems that a customer can design down onto their own printed circuit board. And we have 2 different families. We have an EDM form factor, which is more of an industrial form factor. It uses an edge connector. It's larger. And we also have Pico, which is much smaller, fits in a much tighter footprint. And one of the things that differentiates us, I think, from a lot of our competition, and the reason why customers pick us is that we use the same form factor and the same pinout for every single module that we build. So, for example, we have very low-cost modules in EDM and Pico, with single core processors, slower speed processors, but still pretty functional, including wireless, all the way up to quad-core, higher performance, embedded graphics, embedded vision, embedded video. And we do that in the same exact form factor. So you could build one baseboard, and you could plug a simple, cheap, inexpensive SOM all the way up to a very high functional SOM.
So you could differentiate your product line just by simply swapping out the module.
Yeah, and I think one of the things that a lot of people don't think about is if you're thinking about designing your own system, your own board with processor and module and memory down onto a board, they don't really think about, okay, does that actually add value to my product, right? Now, I'll just give you an example. When somebody buys a Nest thermostat, or they buy a smart speaker, right? How many people, and be honest, we're a embedded world, so if we had that question answered in this environment, everybody would raise their hand, but to the consumer space, and really to the embedded industrial space, how many people really care about what processor's in it and how much memory's in it? The answer is they don't. They could care less. What they care about is that the product works, the product looks good, and the product's reliable, right? And so what my point is that putting a lot of resources into design and development of this little system yourself, right, doesn't make a whole lot of sense, right? What it does make for is a whole lot of engineering time spent in a part of the design that actually doesn't differentiate you. So what we do is we try to accelerate customers' time to market and actually reduce their overall development cost by a considerable bit by using our products. But if they don't want to use SOMs, say they don't have their own design team, we can look at doing a custom design for them, right, with our design team. And we have our own manufacturing facilities in Taiwan, so we can do things very, very quickly and very inexpensively. And then if they want, so for example, if they want single board computer builds, we can do that. Or if they don't necessarily want to do any design, they just want to integrate a panel or a box into their system, we certainly have those products as well that they can use.
And then that's the important thing. You want to offer scalable solutions as well, right?
Yeah.
So this is a box.
Well, this is an embedded box computer.
Mm-hmm.
We have a line of these all the way up through, all the way from low-cost single-core processors, either x86 or ARM-based processors, all the way up to quad-core, x86 and ARM processors. All of them fanless, so that they can work in higher thermal stress environments. So we have that, and absolutely not without fans in them. Because the processors that we put in there, Atom-based processors from Intel, IMX processors based on ARM technology, are inherently power efficient.
Very nice. Now, so where do people go to get more information? What's the URL?
Okay, so you can go to www.technexion.com. That's TECHNEXION.com. For just general information, for support and downloads on our products. We also have, if they want to buy sample quantities, and even a little bit more than sample quantities, we actually have a web shop where you can go and buy parts straight from TechNexion. We ship them all over the world, 2-day delivery. That is shop.technexion.com.
Very nice. So before I let you go, do you have any last words for our audience?
No, just come and see us, come and visit us. If you have any questions for me personally, my name is John Weber. I'm our business development engineer in the Americas. So if you're a US, Canadian, South American, Central American customer, please reach out and talk to me. My email address is john.weber@technexion.com.
Very nice, John. Thank you so much for taking the time at this really busy show.
Well, Alex, thank you very much for hanging out with me and having this discussion. I really appreciate it.